So, good afternoon, and you're welcome to today's class. Generally, we'll be looking at reliable programming. Yeah, from the beginning of the class, we're looking at concepts as it relates to software engineering, the practice, the methods, what you're supposed to consider, security, and a host of other things. You are echoing, sir. Uh-oh. Am I still echoing? Hello? Oh, okay. Ladia Jai, probably is yours. Oh, okay. Thank you, Mr. Deniro. Oh, it's better. All right. Thank you. Yeah, so let's go. So we're looking at reliable programming, and I said that we had looked at different aspects of software engineering. We said software engineering is a practice of delivering good products. We saw different aspects of software engineering. We can hear you loud and clear. Correct. Mr. Ruben, thank you. We have seen different types of software engineering, what you're supposed to do at different stages and everything. The last class, we looked at security, why security is important, security of your program. And we emphasize that security is about, let's not exaggerate, is about the major key to a good software that you are supposed to deliver to a customer. Because if you deliver a good software and there's no security, that means it's free for all and it could be badged in by anybody at any time T. So today we'll be looking at reliable programming. What constitutes good program practice, right? What are you supposed to do? What are you supposed to look at? What are the things you're supposed to look at, do? What are you supposed to test before sending out your products? Different aspects of good programming and techniques. That's what we want to look at. Then, of course, we'll be looking at terms and conditions that constitute what is called reliable programming. So I'm going to be a bit fast, so I hope you bear with me. Today has been quite hectic for me. So creating a successful software product does not simply mean providing useful features for the users. That means after developing, listening to the story of the user, you develop a scenario, you extract the feature, right? So coming up with all that is important, right? But software, a successful product is more than that. It transcends that. So you need to create a high quality product that people want to use. And this must be secured to an extent, right? So that the individual who wants to buy your product, who has paid for your service, will get satisfaction. So, and they're also looking out for confidence in that product that you have delivered to them, so that should there be any error, should there be any crash, they can feel safe and their information is intact per time. And again, recovery from errors, it's also important so that you just don't allow the person to just probably be dangling in the air, right? So it is very important to look at this for any software quality, right? So the attributes you have to look out for is the product you are going to be sending out must be reliable, it must be available, it must be resilient, it must be maintainable, it must be responsive, Then it must be top-notch in usability, and the security must be tight to avoid just anybody getting into your system at will. Then, so what is programming for reliability? Now, there are three simple techniques for reliability improvement that can be applied in any software company. That you must avoid faults, you must validate your inputs, and your failure management must be strong enough. Now, you should program in such a way that you avoid introducing faults into your own program. Now, as we go on, we're going to be looking at some practices that programmers indulge in that introduce bugs or errors into their software or into their program. Now, for big software, maybe beginner programmers, they have a way of writing codes to impress and to make it look so artistic and stylistic. And in the process, they introduce several faults, right? Maybe structural faults, compilation faults, different kind of faults, interaction faults, depending on maybe their basic understanding of concepts, right? Even advanced programmers, even during documentation of their codes, they may introduce complexity into it. Then also the algorithm that you're going to be using, it gives us a lot of, you have to check the complexity of the algorithm. You have to look at the branching statement, the complexity of branching statements. You have to develop well, it's not an algorithm class, but another problem that we have generally introducing complexity to coding is the kind of algorithm you use. Then the types of input you're going to be supplying into the code or into the software product is another thing that may cause that may bring us up to introducing complexity into our code. Then, of course, maybe your knowledge about the technology that you're going to be interacting with. For instance, if you are going to be interacting with nodes, maybe those nodes are embedded, they are sensor based, right? And probably you do not understand how sensors pick up signals and transmit them, and how they be converted into input signals into your program or into your code. That may be a problem. You could also use some libraries that you have not adapted correctly to your code. That may also be some problem. So input, another thing is input validation. You should define the expected format for users' input and validate that all inputs conform to this format, right? So there are methods by which you can force the input to be in the right format, right? Some people can just be, I don't know, they just have issues with simple instruction. They say, okay, enter your name, and you just maybe see them entering their matric number. You'll now be wondering that, how come? So you must put a prompt in such a way that the input will be forced to conform so that your database will not be polluted or corrupted, as it were. Then you should be able to also manage failure. You should implement your software so that program failure has minimal impact on product users. So that means if there's a fail or if there's an attack, I can be sure that, well, maybe my documents are still safe. Then, you know, I had a very interesting experience recently. I was sent a thesis to review, so I had to review it online. You know, I was on the illusion that my review should be saved automatically, and after working for almost 4 hours, I just found out that all my review had gone. It was a very terrible experience. So such failure shouldn't have occurred. There should be a way of retracing what I've done over the time, over 4 hours. Just wasted my 4 hours, for goodness sake. I was working from 12 a.m. to 4 a.m. So when it was 4:30 and I got angry, I just had to go and sleep and let it that way. So if there's going to be a failure, then it should be minimal, not just So what are the underlying causes of program errors? So programmers make mistakes because they don't properly understand the problem or the application domain. Now, programmers make mistakes because they use unsuitable technology or they don't properly understand technology that they are using. Now, programming languages, libraries, database, IDs, etc. Programmers make mistakes because they make simple slip or they do not completely understand how multiple program components work or interact together and change the program state. So this is another major issue that I feel if you're going to be a good programmer, you should learn a bit of logic, right? Oh, I'm talking about philosophy and logic, then logic as it were in computer science, that's CS 303 and 304. You should be able to think at a lower level so that you understand interaction of program methods, classes, or functions. So for a reliable program, you have to look at the program complexity. Now, I teach algorithm and complexity. And what we have found out is that we have the priori and a priori kind of complexity in algorithm. Now, some are dependent on you have to implement, then evaluate, then some have to be at the algorithm level, right? So you just check the input, look at the number of branches, the number of loops, right? Some will be nested loops, some may be flow, and a lot of other things. So you calculate them using different formulas. So as a student of software engineering, I feel that that's a course that you need to audit so that at least you will be abreast with some form of complexity in algorithm. So complexity is related to the number of relationships between elements in a program and the type and nature of this relationship. So the number of relationship between entities is called coupling. So the higher the coupling, the more complex the system is. For instance, if you have to do a lot of looping, nested loop, you are going to have a very complex system or a complex program. And also, if you have worked on was in a compiler construction before, you will see that once a code is written, as I've said earlier, it's usually divided into 4 components. Yeah, data, code segments, then memory segments, right? So you find out that there is a particular memory location assigned to your code at runtime, right? That is usually undetermined. It's called the heap memory structure. Though you have a stack, then there's a heap memory structure that is also assigned in such a way that you may have nested loop that you do not even have an idea of when it will end, because you could have different call and return from a particular point. So it is the heap that will continually manage that, right? But if you know the number, maybe you have a linked list, you have an array, you could make use of the stack portion of the runtime memory, right? So all this introduce a lot of complexity in our programming, in our software product, as it were. So the number of nested loop you are going to have, the more complex your system is going to be. Now, the next diagram we're going to be seeing, we see that we see a figure, a node having several relationships with different things, right? This makes it very complex because if you need to edit a particular aspect of your code, is going to affect large portion of the codes of the maybe modules of code or functions or classes, object that you have created in the whole spiral of code, right? So we're going to be looking at, okay, how can we avoid this kind of complexity? So we have a number of relationships, but we're going to be looking at 2. We have a static relationship, is one that is stable and does not depend on the program execution. So it's just by himself. So so this, this guy now, He has this, and he has relationship with 1, 2, 3, 4, 5 other nodes, which makes it quite complex to deal with or to change. But look at this guy just standing up here. He's just having a relationship. Now look at this guy here, just having a relationship with this one, direct relationship with this. But this guy has a relationship with this one, has a relationship with this guy, with this guy, this guy, this guy. So if you change anything here, it affects all of these guys. And that introduces complexity, as it were. Right? So let's look at types of complexity. Well, that's as it relates to software engineering. However, for algorithm, we look at time complexity and space complexity, which are priori or a priori complexities. So for software engineering, complexity are reading complexity, structural complexity, data complexity, and decision complexity. So the reading complexity reflects how hard it is to read and understand the program. Now, oftentimes, we always say that for every any software engineering company, you should have a practice where the programmers follow a kind of style of writing such that if they decide to leave, somebody else could come, look at their code, understand the code, and make some changes to those codes. But some people, because of their sinister motive, they will just write very cumbersome code, introduce a lot of things that are not even useful, right? So that when the next person comes and say, what was this one? So he may be forced to start all over again. Yeah, I was sent a document to look at. Apparently, the person sent, okay, the person was sent a document. He gave somebody to do something, so the person sent back the document. And the document was, of course, had some issues and we needed to correct it. Now, we found out that we could not even access the document. So instead of me wasting time trying to crack it, all I did was to start all over again. Now, look at the huge time it will take me to start all over again than just to make corrections in what he has done so far. So some people are like that. So reading complexity, if you have a software company, you should make sure that reading complexity of that, of anybody writing, is readable enough, is easy to read, is able to understand for everybody who understands syntax and semantics in that domain of programming language. The structural complexity, this reflects the number and types of relationship between structures, that means classes, objects, methods, or functions in your program. So if you have one interacting with one, it's better. But when you have one interacting with many or 5, as we saw in our previous slide, then it becomes a serious issue. So data complexity, this reflects the representation of data used and relationship between data elements in your program. Decision complexity, this reflects the complexity of the decisions in your program. So if this happens, what is the next thing? For instance, if you have a function calculating Fibonacci, and you have another function, maybe calculating another thing, or maybe factorial or something, how that's the way they maybe the way they transfer function, maybe you have what you call the global variables and the local variables for each of the functions and the main code. How do they transfer results and all that? How they communicate, how their decision affect the overall performance of the program. So how do you now reduce complexity? For structural complexity, so you should make sure that function does only one thing and only one thing. So function should not have side effects. So every class should have a single responsibility it's performing. Minimize the depth of inheritance. Of course, inheritance is when you have things grouped together and one person can get its being from the upper class. For instance, when you say father, mother, you could have man and woman, right? So that's it for just simple example. Then avoid avoid threads, that's parallelism, unless absolutely necessary. though we, in networking, we crave for parallelism, especially in data communication. But here, we just want things to be in series as much as they can. Now, data complexity. Now, define interfaces for all abstraction. Now, I'm sure you understand what abstraction is. That means leaving the complexity of the whole problem you want to solve and abstracting into just smaller elements that could be understood and can be formalized using formalism in a particular domain. For instance, for automata theory and complexity, automata theory and computability, you could use automata as a form of model. So instead of looking at the whole complexity of, okay, where is this fellow? Somebody's battery low. Is it my battery that is low? No, there's lights here now. Okay, your own battery. Or last one come, you look for me, liar. Sorry. So what do you want to do now? Go and charge it now on generator. Yeah, don't mind my colloquialism. Well, it's one of the sacrifices you have to pay anyways. Yeah, sorry, somebody was complaining that his battery is or her battery is low. Sorry about that. Mr. Olanite, please, if you are together with that individual, you could share your screen with the fellow. All right, going forward. So conditional complexity. So, oh, sorry, I think I skipped some. So define abstract data type. I'm sure for those of you who have done algorithms, you know what's called ADTs. Now, avoid using floating point numbers. Never use data aliases. Now, conditional complexity. Avoid deeply nested conditional statements. Avoid complex conditional expression. If then, else, if then, or do. All those ones are too complex. Just write something simple. Now, ensure that every class has a single responsibility. That's just expatiating how to reduce complexity. So you should design class so that there is only a single reason to change a class. So if you don't, if you adopt this approach, your classes will be smaller and more cohesive, right? It will therefore be less complex and easier to understand and also to change. So you should ensure that your class does just one thing. Now, the notion of a single reason to change. Now, what this means is that once you have a class and it does one thing and it interacts with one thing, it's easier to change than introducing another class in a class where it doesn't belong. For instance, you have saloon cars, or you have, okay, let's say you have a super class or cars, right? You can name different names of cars. You can name Mercedes, Lexus, Toyota, Peugeot, different names. Now, imagine that in that main class, that big class of cars, you are now adding trucks. Now, that is a distortion. But some psychophants can argue that, after all, trucks also have 4 tires, right? Some of them have 4 tires, not the long ones that kill people on Lagos Ibadan Expressway. They have long tires. That's some of them have just 1, 2, 3, 4 tires. They have wheel steerings. They have everything in a car. So they want to force them into class. So if you now decide to change and just say saloon cars, does a truck belong to saloon car? No, it doesn't. So you should bring things that are similar together so that if there's a reason to change, it will be easy to change them. So gather together the things that can change for the same reason. Separate those things that changes for different reasons. So remove truck from cars. So this is an example. Now, one way of making this change is to add a print inventory method, right? We're going to look at what that is saying. So this change breaks the single the responsibility principle as He then adds an additional reason to change the class. Okay, let's move on instead of explaining this. So this is what it means. You have this guy, device inventory, you have laptop, tablets, phones, device assignments, right? Now, this is for devices, name of device. The other one, add device, remove device, assign device, unassign device. So this is get defined assignment. This is now, then there's another one here. You have device inventory, laptop, this. Now you see you have print inventory added to it. So this print inventory, how does it correlate with add inventory, remove inventory, assign add device, remove device, assign device, unassign device. Let me put a notation. So look at this guy. How does it correlate with others? Right? So instead of bunching these kind of things up and just coming to fix it somewhere here, this can cause some level of complexity. So what you do in essence is to simply create another class to hold that. So you have your participants set. Okay. So you have the device inventory, you have all this, add devices, you get this, inventory report data, report this. So you had another class eventually where you could add your prints instead of modeling it up, maybe modeling it up at this instead of putting it here. You create a new class entirely to deal with that. All right, moving on. So another way of having a good program is to avoid deeply nested conditional statements. So deeply nested conditional if statements are used when you need to identify which of a possible set of choices is to be made. For example, the function a check in the snippet we have below is a short Python function that is used to calculate the age multiplier for insurer premium for drivers. So the insurance company's data suggests that the age and experience of driver affects the chances of them having an accident. I hope that is true. So premium are adjusted to take this into account. So if you are advanced in driving, then they will feel that you should be very careful, where some of you will still make calls while driving. So it's good practice to name constants rather than using absolute numbers. So the program sequence names all constants are used. So this is snippet of the code. So if the young driver, you assigned a particular code to him, older driver, you have their age, then you will calculate their premium. So this is another method of doing the same thing. So avoid deep inheritance hierarchies. Of course, okay, I think I just made mention of what inheritance is. So inheritance allows the attributes and method of a class, such as a road vehicle, can be inherited by subclasses such as truck, car, motorbike. Now, inheritance appears to be an effective and efficient way of reusing code and of making changes that affects all subclasses. However, inheritance increases the structural complexity of code as it increases the coupling of subclasses, right? I think we already understand what coupling means. For example, the figure below shows the part of a 4-level inheritance hierarchy that could be defined for staffs in an hospital. So staffs in an hospital could have a doctor, nurses, pharmacists. So under nurses, you could have midwife, plenty of them like that. So the problem with deep inheritance is that if you want to make changes to a class, you have to look at all its subclasses to see where it is best to make the change. So which means that, for instance, if you have defined nurses and you put midwife, all those plenty, and you put auxiliary nurses, Then you now say, okay, nurses that could treat patients. Of course, there's a level of treatment that an auxiliary nurse cannot tamper with. For instance, I don't think they are given the license to inject people, right? It's those ones that put on white that can give injection. The other ones that put on purple or green, they are just meant to carry the saucer that they put their syringes and everything around. So if there's going to be a well-defined super class again, that means the nurse that you have, the nurse class that you have defined earlier, you now look at, okay, which one will you remove? How would you remove it that it won't affect the whole super inheritance structure? So this is a problem of having deep nested inheritance structure. It introduces a lot of complexity. So you should avoid that for programming purposes. So you have hospital, whatever, you have clinical staff, you have doctor, nurses, physiotherapists, then you have midwife, ward nurses, nurse manager, and there are some that they called, what do you even call it, CFO or something. CNO, yeah, Chief Nursing Officer. Then you have some again, plenty names that they give them. So design pattern definition. So a general reusable solution to a commonly occurring problem within a given context in software design. So design patterns are object-oriented and describe solutions in terms of objects and class. Now note that they are not off-the-shelf solution that can be directly expressed as codes in an object-oriented language. So they describe the structure of a problem solution, but have to be adapted to suit your application and the programming language that you are using. Now, for instance, if you want to model, I think the stack, the memory stack, the stack, sorry, is it memory? The stack. So it's a memory, it's a kind of memory. If you want to model its function using Automata, so I think a pushdown Automata will be sufficient to model that. So in writing the code, you could now write your own to at least you have a skeletal part that you just add your flesh to that. Okay, this is where you start. This is what you will do. This is the loops you are going to follow. Then you could write your own code to cover the other aspects. So programming principles. So separation of concerns. This means that each abstraction, I'm sure you understand what abstraction is. All right. So abstraction means leaving the complexity of the whole system and just taking the aspects that you want to model or the aspect that you want to deal with. For instance, for those of you who did physics, you know that we say that I think there's one formula called V equals U plus AT, right? I think that's a law of motion, right? So law of motion, what it has done is to just abstract some property of movement representing with the velocity, final velocity to be equals to the initial velocity plus the acceleration times time. So, but does that really capture the whole aspect of a moving car? No. What about the force or the weight of the car, which they say F equals to ma, right? That's another issue that you look at. But instead of you disturbing yourself with all those complexities, you just choose a narrow space that you want to work on. For instance, we say an apple dropped from a tree, right? And it gets to the ground, calculates the time taking. Now, of course, you are not concerned with the tree. It's not your business. All you want to calculate is time. So you look for how can you abstract from the apple, the tree, the leaf, and every other thing that is concerned to just the narrow space that you want to work on. So what do? All you need to do is to just look at the formula H equals to gt squared, where you have your acceleration being equals to 0. So h equals gt squared. You already know the height, so you want to calculate the time. And you know that your g is the gravity, and gravity is constant. So when you have the height, you have your gravity, you slot in 9.8 meters per second squared, or is it per second or per second squared? Then t squared. You make t the subject of the formula and find the root of the other side, and you get, so that is what abstraction means. So this means that each abstraction in the program, that's class method, is should address a separate concern, and all aspects of that concern should be covered there. So we want to calculate time taking. All concerned about time taking should be covered by that formula. For example, if you are going to authenticate, all authentication issues should be dealt with in that space. Now, separate what from how. So if a program component provides a particular service, you should make available only the information that is required to use that service. That is the what. Now, the implementation of the service, the how, should be of no interest to the service user. So it's not about the programmer. So what are the still unreliable program? What are the common types of design patterns that should be looked at? So we have a creation pattern, structural pattern, and behavioral pattern. Okay, so Mr. Easy or whatever, I'm taking your matric number. We'll deal with you appropriately. I don't know why you guys just simple instructions. Right, so paste that is somewhere. Just all right, so moving forward. So creational pattern. So these are concerns with class and object creation to define ways of instantiating and initializing objects and classes that are more abstract than the basic object and object creation mechanism defined in the programming language. Structural pattern. These are concerned with class and object composition. Structural design patterns are a description of how classes and objects may be combined to create a larger structure. So as a structural designer, you should understand how they react. For instance, there's something we learn in chemistry. Of course, I don't like chemistry. They say something is a catalyst that I think it aids the reaction, but it doesn't take part in the reaction. You'll not be wondering, how will something jump inside something and it doesn't take part? Well, just like we all blame devil for all of our issues. That is the devil that caused it, is the devil that caused it. So devil just pushed you. So devil is the catalyst, and you and the other person you are probably having issues with, you are the elements reacting. Yeah, they call it reacting, right? So once you finish reacting, the devil will now run away because he didn't take part. He didn't take part in the experiment or in the reaction. Yeah, you just so you should understand how things react. If this happens, does it have any major effect? For instance, you just write print screen or print maybe in the Python, you print something, I print this. That's just display. It doesn't have anything that is doing. But if you are going to do any form of calculation that is intensive, right, then you will have to maybe do some other things that you should just understand the structure, how they work. What is the effect of this? For instance, let me just use the layman example. For instance, you could have a baby, a small child on your hand. If that child slaps you, you just laugh, hey, how are you? But if you have an adult slap you, ha, I think the devil will just come as the catalyst. Yeah, I think it's catalyst they call it. Just come as catalyst, just shout, ha! Imagine, why did he slap you? But why didn't the same devil come when that small child slapped you? He's just playing with you, hey, mommy, or maybe he's even a baby that doesn't know anything. Just holds your nose and pinches you up, and you're shouting, yay, and the baby is laughing. But if another slaps you, ha! So you should understand how things interact structurally, right? I was listening to a program said if you go abroad and you just raise up your hand and you raise 5 hands to a white man, you will just say, hey, hello. But you just raise up your hand and open your 5 hands to a black man, say, ha, you're abusing me. Let's sort it out today. So you should understand such interaction in coding. I'm just using this layman example for you to understand. So behavioral pattern, these are concerned with class and objects communication. They show how objects interact by exchanging messages, the activities in a progress, and how these are distributed amongst the participating objects. So for instance, when you have nested call, should the database be, should the return, the function, the answer that will be returned from a function, should that function wait for it before continuing its own processes? Will it lead to inconsistency in data and databases and all that? So these are examples of pattern type description. You have creational, structural. So look at that. So look at the example of presenting multiple view of the same data. You could list them and you could have them in tree view. So pattern description. So design patterns are usually documented in the stylized way. This includes a meaningful name for the pattern and a brief description of what it does. So now, you know what we are, why we delve into this? We have classes that you could not just write, that code that you don't have the code existing for it. That's explicit code existing for it, but you could have structured ways. Okay, the first thing is that do this, the next thing, do this. You have an algorithm existing for it. You don't have explicit code. So you now, how do you now describe the pattern for such kind of abstraction? So you could describe it in list form or in tree view. Then how do you now describe the pattern? So design patterns are usually documented in the stylized way. These include a meaningful name for the pattern and a brief description of what it does, the description of the problem it solves, the description of solution and its implementation, the consequences of trade-off of using pattern and other issues that should. I think we have done something on refactoring, right? So that is another good way of doing reliable programming, right? So refactoring means that you're changing the program to reduce its complexity, right, without changing the overall behavior of that program. For instance, some of you would have made use of AI tools, I think, for rewriting your documents, right? The first thing is that you must create a document that it's not AI generated, or even if it's AI generated, but you know, we catch you. So you should at least put it in one of those AI tools to help you rewrite it. Now, for some people, they are not good at writing, but they have good ideas, right? So when you bring those good ideas, even if Granule cannot help you, put it in some of those rewriting. So it will help you rewrite, right, until it looks so standard. For some of you are going to be writing cover letters for further studies or for relocation. It helps you. So, but the major thing is that the whole thoughts that you want to pass out is still retained. So some of you will just put it, okay, let it just rewrite it. Some of those AI tools are so dumb that they will just remove the most important things. And you now be wondering that, what have I written? What's all this? The key things are missing. Names that are supposed to be there have been thrown out in the name of rewriting. So refactoring makes the programs more readable, so reducing the reading complexity. It also makes it easier to change, which means that you reduce the chances of making mistakes when you introduce new features. The reliability of programming is that as you make changes and additions to existing code, you inevitably increase the complexity. The code becomes harder to understand and change. The abstraction and operation that you started with becomes more and more complex because you modified them in ways that you did not originally anticipate. So a refactoring process is as stated. You have start, you smell, you identify refactoring strategy, make spore improvement on strategies completed, run automated tests. I'm sure you are familiar with some of these terms, except this smell. So example of refactoring for complexity reduction. So for reading complexity, you can rename variables, functions, and class names throughout your program to make their purpose more obvious. For instance, you use what we can identify with easily, but if you write add, we know that you are doing addition. If you write more or multiply, we know that you want to do multiplication. Subtract, we know that what you want to do. So structural complexity, you can break long classes or functions into shorter units that are likely to become more cohesive than the original large classes. So data complexity, you can simplify data by changing your database schema or reducing its complexity. For example, you can merge related databases into your database to remove duplicated data held in these tables. Decision complexity, you can replace a series of deeply nested if-then-else statements with guard clauses, right? So these are ways of refactoring and also reducing some of the complexities that we have earlier identified. So post-smell was identified by Martin Fowler, suggests that the starting point for refactoring should be to identify code smells. Post smells are indicators in the code that there might be a deeper problem. Especially when you are testing, just no, this thing is not doing what I asked you to do. And use, for example, very large classes may indicate that the class is trying to do too much things. But one of the rules that we said is that a class should just do something, just one thing. So, but when it's becoming too long, then it's becoming a problem. It's likely to be a problem. It may not be a problem as well, but becoming a problem, just like a student taking 3 degrees at the same time. So he may be able to juggle the whole of them, especially when he's a mature student. But if he's an undergrad, there's a possibility that we drop on board. So this probably, for example, very large classes may indicate that the class is trying to do too much things. This probably means that its structural complexity is high. So example of code smell, when you have large classes, when you have long methods, you have duplicated codes, meaningless name, and unused code. Now, another practice in reliable programming is input validation. Just as I've said earlier, that some people, you tell them to write their names, they write their matric number. You tell them to write their last name, they write their first name. So you must include stuffs that will force them to comply, right? So input validation involves checking that a user's input is in the correct format and that its value is within the range defined by input rule. So input validation is critical for security and reliability, as well as inputs from attackers that are deliberately invalid. So input validation catches accidentally invalid inputs that could crash your program or pollute your database. Now, user input error are the most common cause of database pollution. For instance, we had some tests some times back, and what I saw in my Excel sheet was kind of interesting. Just have responses that are so irrelevant to the questions that were asked. Yeah, so user input errors are the most common way to pollute your database. So you should define rules for every type of input field, and you should include codes that applies these rules to check the field validity. If it does not conform to the rules, the input should be rejected outrightly. So we're going to be seeing methods of how to enforce this. So methods of implementing input validation, built-in validation function. So you can use input validator function provided by your web development framework. For example, most frameworks include a validator function that will check that an email address is in the correct format. For instance, they will tell you enter your email address. As you are entering, you'll be seeing that the box is red. But as soon as you include a valid email, it becomes green. So this is a form of service that you could tap into. So type question. So you can use this type question functions, such as int bracket open and close in Python, that converts the input strings into the desired type. So if the input is not a sequence of digits, the conversion will fail. So explicit comparison. You can define a list of allowed values and possible abbreviation and check input against this list. So if it fails, you let it go. Regular expression. Okay. Now, for those of you who did what's the name? I'm calling compiler construction and algorithm, or even automata and computability. You know what regular expressions are. They give meaning to words. They define what words should be and how they are supposed to be arranged. For instance, when you have, if it rains, the ground is wet. The ground is wet, therefore it rained. So that is the format that you could have. So anything outside of that becomes an error. Another one is that the cat sat on the mat. That is in a regular expression. But when you have the mat sat on the cat, then it's becoming a problem. Though you could define a regular expression to follow that lemma. That, okay, the mat sat on the cat is also correct, which may be one of the production rules that you will use in that line. So rule for making name checking, the length of the name should be between 2 and 40 characters. Characters in the name must be alphabetic or alphabetic character with an accent plus a small number of special character separators. Special separator character. Name must begin with start with a letter. The only non-alphabetic separator character allowed are hyphen and apostrophe. So those are rules that you just use to enforce that names are what they should be. So if you use rules like this, it becomes impossible to input long strings that might lead to buffer overflow or to embed SQL command in a name field. And of course, hackers can go through this. So regular expression are a way of defining patterns. So for instance, the regular expression for the university working organ is that you have the Senate, or maybe you have the council, then you have the Senate, right? Then you have the faculty, then you have the department, right? Then you have the student body. That is how, so anything outside of that, it's really tampering with the autonomy of the university, as it were, right? So you cannot say that a politician should just come and be a faculty member. What he must go through some requisite thing before he becomes a faculty. You can't just say, let me go and contest, and maybe you are in National Assembly, so let me contest and be a dean of a faculty. No, there are rules guiding patterns. So a search can be defined as a pattern, as stated. So, and it explains what that Unix command does. So this is also a name checking function, a snippet of code. Number checking. So to avoid people running anyhow in typing their numbers, there are rules that must be followed. So number checking is used with numerical input to check that these are not too large or too small. Okay, sorry. That these are not too large or small, and that they are sensible values for type of input. For example, if the user is expected to input height in meters, then you should expect a value of between 0.6 for a very small adult and 2.6, which is about the tallest man. So if you are seeing a value of 6 meters, then you know that the person wanted to write feet. So that means there's a problem and it has to be checked so that it doesn't pollute your database. So number checking is important for two reasons. If numbers are too large or too small to be represented, this may lead to unpredictable results and numerical overflow or underflow expectation. If these expectations are not properly handled, very large or very small inputs can cause a program to crash. So the information in database may be used by several other programs, and this may make assumptions about numerical values stored. If the numbers are not as expected, this may lead to unpredictable results. So another thing for reliable programming is to check the input range. So as well as checking the range of input, you may also perform checks on the input to ensure that this represents sensible values. This protects your system from accidental input error and may also stop intruders who have gained access using illegitimate users' credentials from seriously damaging their accounts before they exit or run away. For example, if a user is expected to enter the reading from an electric meter, then you should check this is equal to or larger than the previous meter reading and consistent with the user's normal consumption. Well, except probably the person has decided to open a cold room in his house, so it may increase. Failure management. This is another method of a method in reliable programming. So software is so complex that irrespective of how much effort you put into to avoid faults, mistakes still occur. So you introduce faults into your program that will sometimes allow it to fail. Program failure may also be consequence of failure of external services or components that your software depends on. For instance, if you have to call a service, right? For instance, you want to check maybe the temperature of Canada. Now, maybe the where you are checking for doesn't have the updated value of the temperature, and you have to depend on it. So errors can come in through that. So whatever the case, you have to plan for failure and make provision in your software for that failure to be as graceful as possible. So that just once it crashes, you lose everything. At least you should get small thing and you're done. So failure category could be data failure, program exception, timing failure. So for data failure, the output of the computation are incorrect. For example, if you are supposed to find your age, what you are supposed to do is to subtract the current year from where you are born so that you know your age. So if you have anything different, then there's a problem. For program exception, now the program enters a state where normal continuation is impossible, maybe due to some errors and everything, right? So the control is transferred to the runtime system, which halts execution. For example, if a request is made to open a file and that file does not exist, then an IO exception has occurred. So the communication or the program execution process is transferred to the runtime memory, which runtime system, which terminates the whole program running. So failure effect minimization. So persistent data data in a database of files should not be lost or corrupted. The user should be able to recover the work that they have done before the failure occurred. Your software should not hang or crash. I think I experienced this too just last week. So you should always feel secure so that confidential data is not lost in the states where an attacker can gain access into it. So exception handling, that's when an exception occurs where normal line-by-line execution, normal execution cannot continue. So how do you handle that? So exceptions are events that disrupt the normal flow of processing in a program. When an exception occurs, control is automatically transferred to exception management code. Most modern programming language includes a mechanism for handling this. So in Python, you use these keywords to indicate exception handling. Java use that. So you have execution of code in the runtime management memory. So you have normal process, exception raise, it is transferred to the exception handling class. So auto-save and activity logging. This is another method of failing safe. So activity logging means just having a copy of what the person is doing, not that you'll be having word for word, but at least the key area. Then for auto-save, some of you are at least used to it on your Microsoft Word. When you are typing, you create a name, you save it for. So once you are typing, you just hit saving and saving and saving, and it continues in that respect. So you have auto-save, last save, save the state, crash, then it recovers, command logger, command executed. So you recover to the state where, sorry. So external service failure. So you could be depending on some external services. What about if they fail? So if your service uses external service, you have no control over these services. And the only information that you have on service failure is whatever is provided by the service API. Now, as service may be written in different programming language, these errors can be returned as exception type, but are usually returned as a numeric code. So when you are calling an external service, you should always check that the return code of the call service indicates that it has operated successfully. You should also, if possible, check the validity of the result of the service call, as you cannot be certain that the external service has carried out its computation correctly. So you should always check to be sure that the service you are relying on is actually okay. So these are methods and ways in which we can do reliable programming, right? So these are just, okay, what can you do to improve your software delivery and all that, right? So these are the key points that the most important quality attribute for most software products are reliability, security, availability, usability, responsiveness, and maintainability. To avoid introducing faults into your program, you should use programming practice that reduce the probability that you will make mistakes. Now, you should always aim to minimize complexity in your program. Complexity makes program harder to understand. It increases the chances of programmers' error and makes the program more difficult to change. So design patterns are tried and tested solutions to commonly occurring problems. So using patterns is an effective way of reducing program complexity. Refactoring is a process of reducing the complexity of an existing program without changing its functionality or its outlook. So it is good practice to refactor your program regularly to make it easier to read and to understand. So input validation involves checking all user inputs to ensure that they are in the format that is expected by your program. So input validation helps avoid the introduction of malicious code into your system and trap user error that can pollute your database. So regular expression are a way of defining patterns that can match a range of possible input streams. So regular expression matching is a compact and fast way of checking that an input string conforms to the rules you have defined. So I'm just doing the rule of. So you should check that the numbers have sensible value depending on the types of input expected. You should also check number sequence for visibility. You should assume that your program may fail, and to manage this failure so that they are minimal, they have minimal impact on the user of your products. So exception management is supported in most modern programming language. Control is transferred to your own exception handler to deal with the failure when a program exception is detected. So you should log user update and maintain user data snapshot as your program executes. In the event of failure, you can use this to recover the work that the user has done. Should also include ways of recognizing and recovering from external service failure. Thank you for listening. And we now have the next item on this. Yes, so this is the project assignment that you will do. Yeah, Mr. Olanite, how many groups do we have, please? Coming. 10 groups. All right. Thank you. I'm coming. Let me unmute you so that you'll be able to make posts. Yes, so you can unmute yourself now and speak. So you have 10 groups, and how many people in each group?
10 groups. We have an average of 14 and above, sir.
What is it?
I will share the link to the group now on the chat, sir. We have an average of 14, sir.
14, okay. So I think I need to have all that. So the assignment is this. Assume that the name of your company is Alamu, and adding your group name, e.g. you have Alamu 81723. So this is the format of the group naming that you should adopt, depending on your group. And you add a software engineering contract for the development of a solution to operate it, okay, for some identified problem in a company. So a software as a software engineer or Mr. Lanite. Okay, somebody is talking now. Oh, okay, sorry. You're not in class, sorry. Okay. What was I saying? So as a software engineer or software engineering student, identify the problems you are called to solve, right? Profile a requirement gathering for the problems and document your process with valid pictorial evidence. So develop a product vision for this project. Develop a story. This fellow. Oh, okay, thank you. Copy link. Okay, I'll send the link. I'll look at it later. All right, can you see my screen, please? Oh boy. Can you see my screen, please? Oh, okay, thank you. That's that left the screen. All right. So, right, thank you. Appreciate it. So, develop a product vision for this project. Develop a story and scenario for the problem. Develop peculiar features from the story. Develop a contractual agreement for the terms of reference. Now, the contractual agreement is not that once you are done, you are done. It's just that you can guide yourself. Okay, how much is this person going to pay? What is the duration? How do you want it delivered? What kind of service? So like that. So it's not that once I deliver it to you once, that's all. No, as a matter of fact, you're going to be using the agile process. So using Scrum, document your meetings, assign leaders to the project, list Scrum members, the meetings you have done, product backlog creation, and the refinement that you did. So develop the solution, show customer testing procedure, and adopt the agile method. So show clearly your sprints and other documentation you feel is necessary. So a well-documented write-up is expected at the end of this assignment of not less than 50 pages per group. So a robust working solution of problem solved will be presented at the end of the assignment. So marks are awarded according to participation and outcome of the project. The assignment is due to be submitted on 1st of June. So you elect your group rep. Now you should be aware that during your presentation, I will call any person to defend. And if the person is not able to defend satisfactorily, then all of you will have to bear the brunt of that person's attitude. Now, why I'm saying this is this. You are going to be getting marks for participation. So you should record those who participated actively in the project and those who didn't participate. Now, if an individual does not participate, indicate that the person did not participate. If you are so unfortunate and I call the person and you didn't indicate the level of participation, then you're going to bear the brunt for the whole group. So when I say a solution, that means you must identify a problem, tell us what the problem is, and solve the problem with the use of any programming language that you feel you are comfortable with. So that is the assignment. Another information is this. I feel that I've gone a distance in teaching you this course, right? And the other two, they are just repetition of what we have done today, which is testing and DevOps. So DevOps is just, okay, you write the code and you maintain it throughout the lifespan of the program. So how do you maintain it? What are the best practices? So you could read that up. Then testing of systems. So you test the unit, you test the code, you test this. We have discussed that earlier. So I feel that you should go and read up those two topics. It's not so difficult as there's nothing difficult in what we have done so far. So what I'm saying in essence is that today will be the last day I'm going to be teaching you. The next time we're going to be meeting, you'll be the one that will be teaching me by presenting the outcome of your research findings. Also, being that today is going to be the last time I'm going to teach you, I want to appreciate somebody specially today. Yeah, of course, I don't know the person and I don't know if the person knows me. It's one of your classmates. And the person was quite thoughtful. Now, why did he come to me? I have, what's the name? Lecture 8. And I found out that we're on strike for 8 months, right? And one of your colleagues just reached out to me, just sent a message that, good afternoon, sir, I hope you are fine. I'm not quoting it verbatim because, I wipe out my documents quickly. So he was just checking on me and wanted to know if he could be of any assistance. It's not about, I wasn't really particular about the assistant, but for the fact that somebody I don't know just found my number and was just asking how I was doing. It meant a lot, and I really appreciate